Hi, once again I welcome you for a new topic on wool. This is a very interesting and practical application topic on testing and identification of wool. In this topic exclusively we will discuss and understand about the testing and identification of different kind of fibers in comparison to wool. As we know, there are different kind of fibers like cotton, synthetic like nylon or plastic fibers, then silk and some other fibers we will see in a comparison. Here exclusively we will have different tests like physical or burning test, feeling, then microscopic and chemical test. Whereas some parameters for quality evaluation we have already discussed, that is about measurement of fiber diameter or fiber length or crimpiness or modulation. All these things are related to quality, which we have discussed in earlier topics. So this topic is exclusively for specific identification of different kind of fibers. Here we can see different methods for testing or identification of wool. So the left side, these are the classical methods, basically two types. One is the non-technical test, another B is the technical test. So non-technical test we can say more of subjective type, where we can do the feeling test. By touching and feeling we can understand what kind of fiber is. Another is burning test, which is the behavior of burning of the fibers. So these are, I can say, more of subjective type. And there is technical test, which is done through microscopic test or chemical test. Whereas in the right side diagram we can see the more modern methods like chemical methods, where the amino acid analysis can be done, or lipid analysis, or differential scanning, calorimetry, or spectroscopy. We can do morphological advanced methods like image processing or electron microscopy or light microscopy, and we can also do biotechnological methods like electrophoresis, DNA analysis, or proteomic methods. So these are modern methods which we are not discussing, keeping in mind the syllabus for undergraduates. So we will discuss more on the classical methods, as I have told first, listed in the left side. Here we can see a quick comparison about the different kind of fibers under burning test, chemical test, and microscopic test. So here we are seeing three kind of fibers: wool, acrylic, and cotton. So in the burning test, what we can see that wool is non-inflammable and it will give a hair burning smell. In case of acrylic, it is flammable like petrol and plastic burning smell. And in case of cotton, it is flammable and the smell will be like paper burning. In chemical test, what we can see is it will have a positive reaction with acid and negative with alkalis. In case of acrylic, it will have a positive effect for both acid and alkali. And in case of cotton, it will have negative effect of acid and positive effect of alkali. So positive means it will have more serious effect on the fibers. Then the third method is the microscopic test, where we can see the look of the fiber under the microscope. In case of wool, we can see the scales, that is in the cuticle, and it will be looking almost like fish scale. In case of acrylic, we can see the structure like crystalline, and in case of cotton, we can see it's a non-uniform thread-like structure. There is no uniformity. Now briefly we will discuss about feeling test. The feeling test requires perception if it is to be of any value. So it is more of a subjective type. It is by touching the fiber or the fabric we get a feeling. So that feeling is possible by long experience. So skilled perception is required only after handling many different fibers or fabrics over a period of time. We can develop such skill and experience, and then by touching we can understand what kind of fiber it is. So naturally it has a limitation of this test, because when we are examining the fabrics which has got different kind of fibers, it is difficult to differentiate by touching or through the feeling. So it's a subjective test. It's not very good to differentiate fibers with feeling, but apparently it gives some differentiation with the skill perception by the experienced people. Now we will discuss in details about the burning test. First I will explain briefly how it is done. To recognize the composition of fabrics by the burning test, the sample of fiber, yarn or fabric should be moved slowly towards the small flame and the reaction to heat carefully observed. So either we are going to test fiber or fabric, we have to carefully and slowly we have to put it over a flame. Then one end of the sample should be put directly into flame to determine its burning rate and characteristics. So when we are putting a end of a fiber or a fabric over the flame, we need to observe the burning rate and the characteristics, how it is burning. And the thirdly, the burning order should be noted. When it is burning, it will give a typical smell, and that smell differs between different kind of fibers. Similarly, the characteristic of the ash, such as amount of ash, form of ash, hardness of the ash and color of the ash should be examined. So between the fibers, the amount, form and hardness or color of the ash will be different. Sometimes it is hard, sometimes it is brittle, sometimes it is char like, sometimes it is some other color. So that makes a difference between the fiber in the ash during burning. Here we will discuss little details about the burning behavior and characteristics of four important fibers. First about cotton and silk, and next about wool and nylon. So in case of cotton, when ignited, it burns with a steady flame and smells like burning leaves. So when we burn the dry leaves, how it is, the cotton burning will be like that. The ash left is easily crumbled. So after burning the cotton, the kind of ash we get, it is easily crumbled. Small samples of burning cotton can be blown out as you would a candle. That is, when a small sample is burning, easily by blowing air we can stop it. Then in case of silk, silk is mostly a protein, as we all know from the silkworm. So being a protein fiber, usually burns readily, not necessarily with a steady flame, and smells like burning hair. Because it is having protein, so the smell will be like burning hair, similar. The ash is easily crumbled in this case also, and silk samples are not as easily extinguished as in cotton or linen. So if the silk samples start taking the burning or catch fire, it will not extinguish very easily. That's a difference with cotton or linen. Now we will see the burning behavior in case of wool, and that is how we can identify the fibers. Later I am going to have a direct comparison between different kind of fibers. So here in case of wool, it is also a protein fiber. As I told earlier, it is basically modified protein, that is maximum is keratin. So it is harder to ignite than silk, as the individual fibers are shorter than silk and the weave of the fabrics is generally looser than with silk. So in case of silk, the fibers are very tightly bound after weaving, whereas in case of woolen cloth or fabric, even after weaving, it is more loose. The fibers are more loosely attached, so it is more difficult to ignite in case of woolen cloth or fabrics. Here the flame is steady but more difficult to keep burning. The flame is steady but it will not keep on burning easily. And the smell of burning wool is like burning hair. So after burning, the smell will be like burning hair. Then the next is the nylon. In case of nylon, if we put the fire, it melts and then burns rapidly if the flame remains on the melted fiber. So if the melted fiber is on the flame, it will burn rapidly. If you can keep the flame on the melting nylon, it smells like burning plastic. So in case of nylon, the smell will be like burning plastic. Here we will see a comparison between different kind of fibers in the burning test, how it behaves during burning, and how is the odor during burning, and how is the residue or ash characteristics. So performance at burning, we have three aspects. One is what is the behavior when it is approaching the flame, and then how it is burning in the flame, and how it is behaving when it is taken away from the flame. These three specific characteristics for each fiber we will see. So in case of silk, what we can see is it will shrink away. When it is going towards the flame, it will shrink away. Same thing happens with wool. This will also shrinks away. But in case of cotton, there will be no effect. When the fiber or fabric is going near the flame, there will be no effect. In case of nylon, again there is shrinks away. In case of acrylic, shrinks away. Whereas in case of polypropylene, that is a polythene fiber like plastic. So here it shrinks very quickly. So what we can see is in case of cotton, there is no difference, whereas others are shrinking away when it is nearing the flame. Then next one is in the flame. When it is directly in the flame, in case of silk, it is burned slowly. Wool, it is burning slowly. In cotton, burns readily. That's the main difference in case of cotton. Whereas in case of nylon, burns slowly and melts. Not only it burns, it will be melting. In case of acrylic, burns slowly and melts. So both nylon and acrylic is similar. And in case of polypropylene also, it burns and melts. Then the third aspect when it is on the flame, that is when we are taking it away from the flame, withdrawn from the flame. We have kept on the flame and it is burning slowly, whereas when it is withdrawing, it is self-extinguishing. So in case of silk and in case of wool, both are self-extinguishing. So though it is burning slowly on the flame, when we are taking away from the flame, it will be self-extinguishing. So these are the difference with cotton. In case of cotton, it continues to burn. Even if we take away from the flame, continues to burn. Whereas in case of nylon, often self-extinguishing, not always, often self-extinguishing. In case of acrylic, continues to burn and melt. So in case of silk and wool, it will extinguish. In case of acrylic, it will continue to burn and melt. And the polypropylene also, it will burn and melt even if we take away from the flame. Now we will see about the odor, smell during the burning. So in case of silk, it is having a smell of burning hair. Same in case of wool. But in case of cotton, there is a burning paper smell. When we burn the paper, similar smell will be in case of cotton. In case of nylon, it will be celery, sometimes perceptible. In case of acrylic, it is acrid odor, and in case of polypropylene, it is not very specific smell. Then if we see the characteristic of the ash or residue, in case of silk, it is brittle, swollen, black ash. In case of wool also, it is brittle, swollen and black ash. So if we now compare silk and wool, in all the aspect, both are similar, so it is very difficult to separate. Whereas in case of cotton, the ash will be grey, skeletal ash. So there is lot of difference in case of cotton with the animal fiber. In case of synthetic fiber, nylon, there is lot of difference in the burning behavior. So here the ash will be hard and light color bead like. In case of acrylic, it will be brittle, black bead. In case of polypropylene, it is hard, round bead, maybe light brown in color. So there is difference with the synthetic fiber, its behavior with the flame, and in case of silk and wool, whereas silk and wool having a difference with the cotton fiber. Here once again we will understand the burning behavior in the form of a chart. So the burning behavior of fiber, it could be self-extinguishing or burning continuously. So in this case, if there is a self-extinguishing, then we will have two category. One is burn briefly and the char, another is burn briefly and melt. So that makes two different category. Now when it is burn briefly and chars, there we have to see the order of burning of hair or feather. So if the order is like burning hair or feather, then we have to see the next, the type of ash or the residue. So if it is black, soft, bead-like, then it is silk. If it is irregular, dark ash, then it could be woolen fibers and other fibers, animal fibers. And if there is open lace-like ash, then it is weighted silk. And from the other side, when we see the burn briefly and melts, then these are all synthetic fibers. So if the order is ciliary, then it is having hard grey bead, then it is nylon. If the order of burning asphalt and it is hard tan bead, it is olefin. The order of sharp acid chemicals, then it can be hard black irregular bead, then it is modacrylic fiber. And if the order of sweet chemicals, it has two possibility, that is hard black irregular bead, then Vinian fiber, and it is hard black round bead, then it is polyester fiber. So this is more on the synthetic fibers and their comparison with the animal origin fibers during burning. So now we will discuss about microscopic test. Earlier we have seen the feeling test and burning test. More details we have discussed about burning behavior. In the microscopic test, to identify the fabric with the help of a microscope with a magnification of minimum 100 power. So with 100 power magnification under the microscope, we can see the characteristic and appearance of the fiber, and we can identify what kind of fiber it is. The test can easily distinguish between fibers, and the test identifies the natural fibers more easily. So more than the synthetic fibers, natural fibers are more easy to identify by their characteristics under the microscope. So first we will discuss about the cotton. So it is a single elongated cell. It looks like a single elongated cell as we are seeing in the picture at the bottom right. Under the microscope, it resembles a collapsed, spirally twisted tube with a rough surface. So whereas in the photograph in the top, we can see that is the picture of a synthetic fiber, whereas in the bottom we can see the picture of a spirally twisted tube-like structure in case of cotton. The thin cell wall of the fiber has 200 to 400 convolutions per inch. So in the outer surface or the cell wall, we can see the convolution in large number. So this is the typical characteristics of cotton fiber under the microscope. Now we will see the microscopic structure in case of wool. So under the microscope, wool's cross section shows three layers: cuticle, cortex and medulla. Actually, if it is pure wool, we can see only two, that is cuticle and cortex. If it is little bit rough on coarse, then we can see the medulla. So in the picture here, we can see that either the presence of cuticle and cortex, or sometime cuticle, cortex and also medulla, depending on the type of fibers or diameter. In case of silk, under the microscope, it appears somewhat elliptical and triangular in cross section when we see under the microscope. So in the middle picture, we can see it's the cross section like a triangular shape. It is composed of fibroin consisting of two filaments. The fibroin consisting of two filaments called brine, which is held together by sericin. So this is a typical difference in the structure in case of silk under the microscope. Here we will see the structure of nylon under the microscope. The basic microscopic appearance is generally fine, round, smooth and translucent, that is not transparent. So here mostly it will be fibers will be fine and round and smooth and mostly translucent or opaque. It is also produced in multilobal cross-sectional area. Multilobal cross-sectional area. So these are the specific characteristics of nylon fiber under the microscope, as we can see in the picture both sides. Now we will discuss chemical tests. So this is coming under the technical test. Chemical tests are another technical means of identifying fibers, but chemical tests are not intended for the general consumer. So it cannot be done by the general public. It has to be done in a sophisticated chemical laboratory or research laboratory. So different types of chemical tests are undertaken to establish the identity of the fibers or fibers used in the cloth or fabrics. So these tests give accurate and precise analysis. The chemical tests are more accurate and precise, and tests are conducted in good laboratories or research laboratories. So this is briefly about the chemical test. We will see the different chemical tests next. Now we will briefly see about the types of chemical test. The first one is stain test. So this is also called double barrel fiber identification or DBFI. This is based on the theory that each fiber has its own distinct two-color reaction when treated with stains. So generally these fibers have two-color reaction when it is treated with stains. So a fiber will turn into a particular color in the presence of dilute acetic acid. When we do the staining in presence of dilute acetic acid, it will take a particular color. But same thing when we are keeping under alkali and do the staining, it takes a other specific color. Another specific color it will take when it is kept in alkali. When it is kept in dilute acetic acid, it takes a color. When it is kept in mild alkali, it takes a different color during staining. Similarly, there is another test called solvent test. So this test involves treating the fibers in certain solvents for identifying them. But technically these tests are becoming difficult because most of the synthetic fibers and their blends are chemically similar. So many of these synthetic fibers are having the similar content chemically as the synthetic fiber composition. So there is no individual chemical or solvent test for separating or identifying the fibers in combination. There are different kind of synthetic fibers are used in combination. Then it is very difficult to identify them in chemical test or solvent test. In addition, earlier I have discussed about the acid behavior and alkali behavior. So in case of wool, they are more sensitive with alkali, whereas less sensitive in acid, particularly in dilute acid or sulfuric acid, it is not much affected. Here we will see a comparison of each fiber in their characteristic about composition, microscopy and burning test. In composition, mostly we will see what is made up of. In microscopy, we can see their structure longitudinal or sectional. And in burning test, we can see three things, that is how it is burning, what is the smell and what is the residue characteristic. In case of cotton, it is made up of cellulose and the structure is kidney or bean shaped in cross section, and the burning is rapid, bright afterglow, smell like burning paper, and residue is pale grey powder. In case of linen, it is made of cellulose, it is irregular polygon structure in microscope, and the burning is rapid, bright afterglow, same as cotton. The smell is like burning paper, similar to cotton, and the residue is pale grey powder, similar to cotton. In case of wool, it is made up of keratin, that is a modified complex protein. The structure, it will be almost round or oval in cross section. The burning will be slow and sputtering, and the smell will be like burning hair, and the residue will be friable cinder or black particles. Now we are almost at the end of this lecture. So we will discuss briefly about the advantages and limitations of technical test. So the advantages are these technical tests are more reliable than the non-technical tests. They are used for both man-made fibers and natural fibers, that is from the animal origin. We are more interested about the wool and other specialty fibers, and these tests can be conducted easily. The limitations are certain manufacturing and finishing processes like mercerizing affects the appearance of the fibers under the microscope. Very dark colored fabrics cannot be identified under microscope. If the fabrics are very dark color, under the microscope we cannot see the fiber. Dye stuffs must be removed from the fabric. So many cases the fabrics are dyed or colored, so that color should be removed before putting in the under the microscope. So these are some of the advantages and disadvantages of technical tests. So now we are at the end of this lecture. So briefly I will sum up. We have discussed about the testing and identification of different kind of fibers with special reference to wool and other animal origin specialty fibers. But we have seen three different kind of tests. First is technical and non-technical. In the non-technical we have feeling test, and in the technical category we have burning test, and then microscopic test and chemical test. But most of these tests are not very foolproof in modern era. So that much only we can discuss under the lecture, under this lecture as per the curriculum. But the modern science, there is so much of advancement. There are very specific and sensitive methods which I have mentioned earlier. So those methods are like morphological methods, chemical methods and biotechnological methods. In biotechnological methods, we can see the electrophoresis, DNA analysis or proteome. In case of chemical, further we can see amino acid, lipid or scanning calorimetry or spectroscopy. And in the morphological methods, we can see image processing or electron microscopy. So these are the further details we can discuss sometimes separate lecture for the postgraduate students. Thank you. Hope this becomes useful.